Hi everyone. So in this video, we are going to talk about inverses of functions. So why do we need inverses of functions? Because many times we have to work with the inverse of functions just to solve an equation or sometimes to analyze a problem. Uh, First of all, we need some definition to go for the inverses of functions. The first definition is one-to-one functions. So a function is called a one-to-one function if f of x1 is equal to f of x2 implies x1 equals x2. So like for instance, an example here, if we have, let's say a set which has elements 3, 2, 1, and then a second set with the elements 7, 8, 9. Let's say f be a function sending 3 to 7, sending 2 to 9, and sending 1 to 8. So in this case, as we see, every number is mapped, every input is mapped to exactly one output. Okay, so this function, this example is a one-to-one function. But let's give another example for a function which is not one-to-one. Take the second one. We call this function, let's say g. Again, we have the same sets. So when we look at 3, g takes 3 to 7, and g takes 2 to 9, and g takes 1 to also 7. So then what happens here? You see that g of 3 and g of 1 are both 7, but 3 is not equal to 1. So then this case is not a one-to-one function case. So as you see, every input is mapped to exactly one output, and there is no other second output which is mapped to the same output. Okay, so every output comes from exactly one input. So that's the definition of a one-to-one function. So a one-to-one function is a function such that every output comes from exactly one output, one input, and no two inputs have the same output. No two different inputs are mapped to the same output. This is exactly the definition of a one-to-one function. So there is a test. If we have the graph of a function, for instance, this is called a horizontal line test. So every one-to-one function, when you make it intersect with horizontal lines, the horizontal lines intersect the graph only once. So a function f is one-to-one if and only if no horizontal line intersects the graph of f more than once. For instance, let's think like of some examples. Let's say f of x equals 2x plus 1. This is a linear function. If we sketch the graph of this function, if x is 0, f will be 1. So for 0, we will have 1. For x equals 1, we will have 2 times 1 plus 1, 3. So let's say here, 1 will be mapped to 3. and then we will have a line passing through these 2 points as any linear function. So let's say you intersect this with horizontal lines. As you see, all of them intersects the graph only once. You can think of other horizontal lines, but as you see, they will intersect only once. So f is 1 to 1. In particular, all linear functions are 1 to 1. All linear functions with non-zero slope. Non-zero slope means, if you have a function, linear function, you will have an equation like this here, mx plus b. So here, non-zero slope means m never zero, r 1 to 1. Let's say we have another example. Let's say f of x equals x squared, the parabola we know. Now, if you sketch the graph of a parabola, for 0, 0 squared will be 0, so 0, 0 is one of the points on the graph. If you take 1, x equals 1, then 1 squared will be 1, so you have another point here. But if you take minus 1 squared is also 1, so it's a parabola passing through these 3 points. But very obviously, if you make it intersect with horizontal lines, it intersects more than once. Let's say this one, this point, this point, this point, this point, more than once. So this means this function not 1 to 1. Or also you can write it this way, f of 1, which is 1 squared, is also equal to f of minus 1, because minus 1 squared is also, minus 1 times minus 1, which is also equal to 1, right? But 1 is not equal to minus 1. And that's just the, this is not satisfying the definition of a one-to-one function. So as you see, x squared is not a one-to-one function. And it doesn't also pass the horizontal line test. Now, what about the inverse functions? So inverse functions are one-to-one functions. That's why we cared about one-to-one functions. So inverse functions are denoted by f to the superscript minus 1, meaning inverse. That minus 1 means inverse of a function f. So let's say f be a one-to-one function from, with domain A and range V, then its inverse, which is denoted by f to the minus 1, which means inverse of f, not 1 over f, by the way. Okay, this is just the notation for inverse function. If you see f to the minus 1, that is inverse of f function. So this will have domain B and range A, because, or you can also write it this way, f of x equals y, then if and only if f inverse of y is equal to x. So if x is mapped to y by the function f, then f inverse maps y back to x. That's why it's called also inverse. It's just doing the inverse of what f is doing. Just let's say, think about some examples. Let's say we have a, b. Let's say this is 1, 2, 3. let's say this is 7, 8, 9. Let's say this is f. Then what's happening here? F is taking 1 to 8, 2 to 9, and 3 to 7. But F inverse, so this is F. F is from B to A, and what is B? 7, 8, 9, and A is 1, 2, 3. So 7 came from 3. So F inverse is going to take 7 back to 3. It's going to take 8 back to 1. And it's going to take 9 back to 2. This is what F inverse is going to do. As you see, it just does the inverse of what F does. Okay, so F inverse does the inverse of what F does. That's why it's called inverse function of F. And as you see, the domain of F is the set A, and the range of F is the set B. But look at F inverse. Domain of F inverse is B, and as you see, the range of F inverse is just the opposite, A. Okay? But let's now do general examples. Let's say, for instance, let f of x equals 4x minus 3. Then is f 1 to 1? B, if f is 1 to 1, then find its inverse. So let's do an example like this. First of all, how are we going to show if f is 1 to 1 or not? So what was the definition of 1 to 1 is f is 1 to 1, remember, if and only if f of x1 equals f of x2 implies x1 equals x2. So let's take f of x1 equals f of x2. Let's say we have this. Then what is f? F takes the input x, multiplies it by 4, and then subtracts 3. So it's going to do the same for x2. So it's going to multiply it by 4 and not subtract 3. So if we add 3 to both sides, what are we going to have? 4x1 equals 4x2. And then if we divide both sides by 4, what are we going to get? x1 equals x2. So what happens? This means, well, we show with 3 dots. This means consequence or result or conclusion. This function is 1 to 1 because we have shown that f of x1 equals f of x2 for this function implies x1 equals x2. So this function is 1 to 1. Then we can show that since f is 1 to 1, it has an inverse. But now how are we going to find f inverse? Okay, for this case, we write f of x equals y. So then this means 4x minus 3 equals y. Then we solve for x. Solving for x means isolate x alone. Okay, so solve for x means we will see this direction many times in the later problems. So solve for x means isolate x alone on one side of the equation. Now, what does this mean? So we don't want 4, we don't want minus 3 on the left. We want only x on the left. So take this 4x minus 3 equals y equation, add 3 to both sides. Then this is going to give us 4x equals y plus 3. And then we don't want 4 now, so divide both sides by 4. And what do we get? X equals y plus 3 over 4. And then last thing, switch x and y to get f inverse. Remember, x was the input of f, y was the output for f. Now, remember, y is going to be the input of f inverse, x is going to be the output. So when we switch x and y here, we are going to have y equals x plus 3 equals 4. And this time, y, when we switch, we actually get f inverse. Now, let's try this function, whether really it gives the inverse. So f of, let's say, let's try this for some number, random number. Let's say x equals, uh, let's say 1. Then what's going to happen to 1? 4 times 1 minus 3. This is what's going to happen. And then this is 4 minus 3. Well, it's also equal to 1. Okay, let's change this number because we don't want the same number. So let's have something else. Let's say 2, x equals 2. So what will happen to 2? 4 times 2 minus 3, which is 8 minus 3, which is 5. So this is what the function does, right? Remember, f of x equals 4x minus 3, but f inverse of x equals x plus 3 over 4. So now, take 5 and apply the f inverse rule, 5 plus 3 over 4, right? This is 8 over 4, which is 2. As you see, 2 was mapped to 5. So 2 was mapped to 5 by the function f, but f is mapped back to 2 by the inverse function. You can try this with other inputs, and you will get the same result, okay? And how do we find f inverse? We write f 4x minus 3 equals y equation, and then we solve for x, which means we try to isolate x alone on one side of the equation. So we don't want first minus 3, so we add 3 to both sides. And then we don't want 4, so we divide both sides by 4. And then we have x alone. And then on the other side, there is some y expression. And then we switch x and y to get f inverse. So we switch x, we make it y, we switch y, we make it x, and then we write this is f inverse formula. F inverse is x plus 3 over 4. This is a division also for plus 3. And as you see, we can try any input, like in this case, we tried 2. 2 is mapped to 5 by f, but then 5 is mapped to 2 by f inverse. So it just did the inverse of what f did, okay? So this is how we find inverse function. Let's do another example. Let f be equal to, let's say, x cubed plus 5, okay? First, show if f is 1-to-1 or not, then b, if f is 1-to-1, then find f inverse. So how do we show if f is 1-to-1 or not? Well, we write f of x1 equals f of x2, and we want to show whether x1 is equal to x2 or not. So if this is the case, then x1 cubed plus 5 equals x2 cubed plus 5 also. Subtract 5 from both sides. X1 cubed equals x2 cubed. And then take the cubic root of both sides. To get rid of that cube, what should we do? We have to take the cubic root. So we take the cubic root of both sides. As long as we do the same thing to both sides, like adding the same number, subtracting the same number, dividing both sides by the same number, or taking the same root of both sides, we are going to have the equation again. But taking cubic root means what? That's cube of x1 to the power 1/3. Same on the right side also. X2 cube to the 1/3. And power over a power means we multiply the powers. And that means 3 over 3 is 1. X1 to the first power, x2 to the first power. First power of any number is same number. Well, what happened? If f of x1 is equal to f of x2, then x1 is also equal to x2. So f is 1 to 1. So f inverse must exist. Okay, so let's do the second part. Now, we write y equals x cubed. What was the function? Plus 5. X cubed plus 5. So solve for x. Y minus 5. So we subtract 5 from both sides. Y minus 5 equals x cubed. And then take the cubic root of both sides. Taking the cube of x cubed will give us x, just like before in the a part. So this is, then switch x and y. It's the cubic root of x minus 5. Because remember, this is now we switched x and y. So x became y became x. So the inverse of this function is cubic root of x minus 5. Let's try this. Let's try x equals, let's say, 1. Then what will f do for 1? It's going to take its cube and then add 5. Cube of 1 is 1 times 1 times 1 plus 5. That's 1. So that's equal to 6. Now, take 6 and apply f inverse. And we should see that this would give us 1 again. So cubic root of 6 minus 5, which is cubic root of 1. But how do we take cubic root of 1? We can always write 1 as 1 times 1 times 1, right? This is still 1. But then writing it this way will mean 1 cubed and the cubic root, that's 1 to the 3 to the power 1/3, multiply the powers, like power over a power, they are multiplied. So 1 to the first power, but the first power of any non-zero number is, or actually any number is 1. And what happened? So it gave back what we have started. So 1 went to 6 by the function, and then as you see, f inverse took 6 back to 1. Okay, so as you see, it really does what the inverse of what f does. Okay, so this is how we find the inverses of functions. There are other inverse functions which I'm gonna talk on the next video, but if f of x, this is another example, but I'm gonna work on this more. So if f of x is 2 to the x, then this is a one-to-one function, and its inverse is called log function, logarithm in the base of 2 of x, okay? Or f of x equals, let's say, 3 to the x. This is also a one-to-one function, and its inverse is log 3 of x. And There is this also other function which we will work very often, e to the x. Here e is this number, remember 2.718. It's a transcendental number like pi, and its inverse has a spatial name, ln, natural logarithm. It's actually same as log e of x, but the notation is, we don't write log e of x, but the notation is rather ln of x, natural logarithm. So natural logarithm of x. Other examples which we will have to deal with are, let's say, f of x equals sine x, then its inverse is written either this way, sometimes like inverse of sine, or sometimes it's written arc sine of x. This is the inverse of sine. And for the others, there are similar functions. If the function is cosine x, then its inverse is arc cosine. Or one more, which we may see also. If the function is tangent, then its inverse is arctangent of x. And then there is one more useful information about inverses of functions. That's the graph. So the graphs of inverse functions. We will use this also. This is a very useful fact. So let's say, so these are actually the graphs of inverse functions are mirror image of the graph of the function. So the graph of inverse function, this is true for all functions. So let's say we have the graph of inverse function f of f inverse, then it's the mirror image of the graph of the function f, but mirror image with respect to what? With respect to the y equals x line. This is going to be also a very useful fact. So let me show what I'm talking about. For instance, let's say we have the exponential function. Let's see, 2 to the x. Okay. Then, to get the inverse of 2 to the x, so let's say this is f of x. Well, the inverse of 2 to the x function, if we first draw y equals x line, remember y equals x line looks like this. The inverse of this function is going to be this way. So it's going to be this way. Like if this, if you give x equals 0, 2 to the 0 will be 1. And if we take the log function, this is f inverse, which is log 2 of x. And this point here, if you give x equals 1, log 2 of x will give you 0. Okay? So this point, I mean, so the mirror image, if you draw perpendicular lines from the graph to the y equals x line, they will be exactly equal. Like this point will be same length. Or this distance and distance will be exactly same. Okay, so it's going to be the mirror image with respect to y equals x.